Hello everyone. Welcome to Korea Blockchain 2020. My name is Prateek and I'm a researcher at Marlin where we work on optimizing the network layer for Web3. In this video, I'm going to talk to you about network layer for Web3, and at the end of the video, you will get a glimpse of the areas of improvements from network layer perspective and how Marlin can help in achieving them. Blockchain technology is nothing short of a revolutionary decentralized system where nodes validate, share, and preserve data. For an industry that's a little over a decade old, things keep moving pretty quickly based on the new findings in research, and there is a lot of research effort going into the industry. One of the areas which hasn't seen a lot of research in blockchains is the networking layer. The efficiencies of the networking layer in blockchains is significantly lower than the Web2 world. Marlin protocol was developed to bridge the gap between the performance and scale achieved by Web2 and the security and decentralization demanded by Web3. We currently focus on two specific problems in the networking layer for Web3, which are incentivized protocol for block and transaction propagation in blockchain networks and incentivized protocol for improving dapp performances to Web2 speeds. Let me first introduce you to Marlin protocol, which solves block and transaction propagation in blockchain networks by creating an incentivized network for propagation of data. Let us look at what are the issues with the current block propagation and how these can be solved with Marlin protocol and how exactly does the Marlin protocol work. Later on, I'll introduce you to Marin Cache, one of our latest projects, to improve the performance and UX of Dapps to Web2 speeds. Okay. In blockchains, the mechanism through which nodes come to agreement on the data that is considered valid is called consensus. And blockchain nodes require to communicate through network layer, which is the layer zero of blockchains, to come to consensus on the state of the ledger. Most blockchains use a P2P mechanism known as gossip protocol to propagate, validate, order, and create and come to consensus on the set of transactions, making them trustless. Uh, gossip gossip involves a node forwarding block to its neighbor, which in turn forwards the block to their own neighbors in an ad hoc manner, not using the most efficient paths, leading to several round trip times. So the number of hops needed for the block to reach the receiver goes up, increasing the amount of bandwidth wasted. Moreover, at every hop of the path, the blocks are completely downloaded, verified for the validity, and only then forwarded further. This results in significant delays in data propagation in blockchains. Uh, as the honest nodes take longer to receive a block, competing validators might propose an alternate block during that interval at the same block height, resulting in a higher orphan rate or fork rate, or attacks similar to selfish mining. This incentivizes miners to co-locate in geographical proximity or coordinate for better network connectivity amongst themselves, disincentivizing miners who are not part of that coalition. This ultimately risks centralizing the network making it much more vulnerable to attacks, with the only choice being foregoing higher throughput. Uh, Focusing on the network layer, we are redesigning communication in decentralized networks by creating a unique economic incentivization model. The outcome is a blockchain agnostic plug and play solution that allows nodes to communicate faster and transfer a greater amount of data in a shorter time span, thus increasing the transaction throughput. Marlin protocol ensures competition between relays to earn fee, which results in increased propagation speed for the blockchain nodes in the network. Incentives for the message propagation helps relays provide better service compared to existing network where such incentives doesn't exist. It can be used it can be used in conjunction with the existing P2P layer as well. Incentives, as with any other decentralized protocol, are crucial to bootstrap the demand and supply side of this bandwidth markets. So we have come up with a novel way called Flowmint to bootstrap the network by distributing tokens among different blockchain communities while also incentivizing its usage. It ensures that absence of tokens is not a barrier for potential node operators. Validators who run Marlin gateway nodes and actively send and receive blocks via Marlin network can register as validators. Uh, Delegators who hold tokens of the blockchain the Flowmint is supported for can stake their tokens with whitelisted validators who use Marlin network and receive rewards for the same. So we have covered till now in the presentation we have covered the how Marlin protocol works and what it serves. In the next part of the presentation, I'm going to introduce you to Marin Cache, a simple API that speeds up blockchain queries. We'll begin the presentation with a short intro to the current state of the app ecosystem, issues with it, and what can be done better, and how does Marin Cache help. We'll also look at how exactly does the cache work and how you as a developer can use it to decrease query latencies for your application. We hope that you will find it super easy to get started with Marin Cache. In recent times, Ethereum has seen an explosion in the number of dApps as well as the users who use such dApps. And if you look at the summary below, there are some interesting observations. For one, most of the users are new to the ecosystem. And secondly, DeFi related dApps account for about 97.5% of the total activity. An implication of these statistics is that DApp developers are having to work hard to improve user experiences. Long gone are the days when users had to directly interact with complex smart contracts. High stake transactions can now be made using simple web interfaces which resemble Web 2 experience. And this is very essential as we transition from early adopters to mass traction. Users now need little to no knowledge of blockchains to use these DApps. However, these interfaces only act as a proxy to connect to a blockchain and present data in a simplistic way. The data presented in these UIs still has to come from a blockchain. So how do developers retrieve data from blockchains? They might either run a full node or archive node as per their requirements on their own. But running a node reliably so that there are no disruptions for the users is hard and resource intensive. Alternatively, centralized services like Infura, Alchemy provide reliable infrastructure to obtain blockchain data for dApps so that dApp developers can concentrate on building dApps rather than running the infra. In the recent times, decentralized networks like Graph are trying to make data extraction even more easier for the app developers by supporting custom indices tailored to each DM. However, these services, centralized or decentralized, are still required to operate a full node. The requirement of operating full nodes to support blockchain queries places performance overheads. For instance, take this host with a 145 Mbps downlink. It still takes more than 10 and a half seconds for uniswap.info to load. And a large part of the delay is attributable to API calls it makes to the graph servers, each of which take 300 milliseconds or more to respond. Uh, these delays we've talked about have implications. Users are fine with such delays today as they consider themselves early adopters, but this might not work as more retail users who are accustomed to Web2 try these services. As can be seen here, page load time has a strong correlation with bounce rates. If the load time increases from 1 second to 10 seconds, the probability of bounce increases by about 123%, which is very high. Uh, so what's the primary cause of such delays that are higher than 300 milliseconds? The response times are high because currently Graph operates centralized services due to which the latency between host and server is higher due to the geographical separation between them. Also, Graph node has to run a query on the DB to get the information to be sent to the user. The closer the client is to the server, the lower the latencies, but the experience of users is not uniform and worse for users who are in faraway regions. So, how do we solve this? So, decentralization of nodes can help bring indexes close to users, thus decreasing latencies. Indexer nodes in graph are the ones that respond to queries on a subgraph data for a DM. High resource requirements of graph indexer nodes limit the number of locations that a node can be placed in. Graph's indexer node needs to run an archival node to query most famous subgraphs, which puts a heavy resource requirement on running an indexer node. So, the barrier to entry for an indexer is high, which in itself is a reason why graphs indexer nodes cannot be very highly distributed to make these latencies go away significantly. It is evident from our from the measurements of the current testnet that the graphs nodes are not very distributed, as most of them run on Hesler Online services and mostly out of Germany. So, how do we do better? How can we solve these problems? Instead of a instead of a resource intensive indexer node, a low resource node which stores the responses to frequent queries and responds directly when same query is made can scale better. These can decrease the load on the indexer node as well as improve the latencies for the users. Data is in the current blockchain platforms, the data is updated only once in a block time. So about 15 seconds in case of Ethereum, which is large enough time that caching is more efficient than querying the DB for data for every request. These nodes can be distributed widely across the world due to their low resource constraints. These type of nodes which store responses to frequent queries and respond directly thereafter are called caches. Cache nodes that are significantly distributed across the world are called CDNs. CDNs today solve a similar problem in Web2, and Marlin Cache is an attempt to solve these issues in Web3 world. So Marlin Cache is based on a simple observation that most of the user activity is from a very few dApps. We can see that from the screenshot below. You can you can see that Uniswap accounts for around 250 to around 260k users, while the maker DAO or while Aave accounts for 7.7k. So a large portion of users access very small number of dApps. Marlin Cache is an event-driven caching system, which means that the data that is cached is only updated once in a block. And some of the cache data can be directly updated by Marlin Cache itself based on block information without querying the source again for the data. So how exactly does Marlin Cache work? So when a user sends a request, Marlin Cache requests the data from the source, caches the responses. If another user requests the same data, which is very frequent as most of the users use the same interfaces to interact with dApps, the cache data is served to the users. Cache updates the cache data by querying frequently requested data from the source. When cache knows that the data is updated, most likely when a new block event is received, these pre-filled responses are provided when the same query is made, which decreases the latency of the users. Some of the cache data can be updated without requesting data from the source based on the block information received, which will further improve the consistency of the cache with the current blockchain network state. We also ensure that the data within a cache is consistent and corresponds to a single blockchain state. So currently, so now that we went through how exactly, like what exactly cache solves and how exactly does cache work, let us look at what we currently support and how someone who is developing a DApp can use Marlin Cache. So we currently support caching for Infura and the graph. Marlin Cache is very easy to integrate both for Infura and Graph, as it is a drop-in replacement for both the services. If you want to find out more about how to integrate your dapp with Marlin Cache, you can find that in our documentation. The link is there in the slide, and slides will be shared. Uh, okay. Okay, so yeah, that's more or less what we do and what are the challenges with current networks, current decentralized networks, and how Marlin can help solve some of these issues. If you have any queries, you can always reach out to us on our Discord. And if you'd like to know more about what Marlin does or discuss about decentralized networks, like just drop by in our Discord chat, and we are always there. Also visit our website and follow our social media platforms for more info and updates on our project. Thank you.